All right, so welcome to chapter 4. Again, you guys will be watching this video at home and taking notes. We're going to go through the introduction of the structure of an atom. We're going to be talking about the history and how it was discovered. You guys will be doing a web quest with the history of discovering the atom and all that. So you guys will do that aside with the atomic theory and what we're going to be looking at for the introduction of the structure of atoms. All right. So when we talk about the history of the atoms, we're going to talk about how scientists were able to discover protons, electrons, and neutrons. Okay. And so the person that was able to discover this atom or the idea of it will be talked about later, but he was able to predict with different observations. Again, he might not have had the tools to observe and identify, but he was able to come up with different theories to explain how atoms were and what the function of the atoms are. Okay? And so when we define an atom, we know that atoms are going to be very small. So if we talk about size comparison, if we look at a copper coin, so like a penny, that's going to contain 2.4 times 10 to the second atoms. That is a very, very large number. If we were to compare that to Earth's population, there's a big difference. I mean, we're talking about a 13 exponential difference. So you're adding 13 zeros on to that 2.4, well, 22, but 13 more zeros than you would to 7 billion. All right, so Earth's population is around 7 billion, but what we see is that there's a huge difference. So if we were to even line up just 100 million copper atoms side by side, that would only produce 1 centimeter long of a distance. So again, when we talk about atoms, very, very small. To the naked eye, we can't see it. Okay, we can't observe it, but we have special instruments that allow us to see it. So again, we use electron microscopes to help us observe atoms of different kinds. So we talk about the scientists that came up with different theories. And so this guy's name was Dalton, and he came with Dalton's atomic theory. And so parts of it were true, parts of it were eventually proven incorrect. But again, with the type of technology he had back in the day, with the certain instruments that he had, he was able to come up with this theory. And so the first part of his theory explains that all elements are composed of tiny, indivisible particles called atoms. This was later debunked because what we see if we take a closer look at atoms is that they are divisible. They're made up of protons, they're made up of neutrons, and they're made up of electrons, okay? So it's not like the atoms are one core thing. What we see is that, no, they are divisible by some way. They are made up by other things. He also stated that atoms of the same element are identical. So the atoms of any one element are different from those of any other. So his idea was if you had an oxygen atom, you're going to have the same oxygen atom. There's no difference to it. However, what we know now is that there are differences within atoms. You can have isotopes. And so we'll talk about isotopes later in class, but with isotopes, it's showing that there's going to be different kinds of atoms within the same element. What he did get true, and it is still true today, is that atoms are going to combine in simple whole number ratios to make compounds. So, for example, if we look to the picture to the right, atoms of element A and atoms of element B can come together and they can create a compound. All right. So what we see is that these atoms are essentially just rearranged. They're never changed into atoms of another element as a result of a chemical reaction. So what we see is that they stay the same. They're not going to change essentially their whole identity by creating these compounds. Again, think of it like Lego blocks in a sense, right? Yeah, the individual Lego blocks are going to come together and create some type of compound or some type of structure. So again, we talk about back in the day, we talk about John Dalton and how he was able to study atoms even though he couldn't observe them, right? He didn't have the electron microscopes for him to observe what we see today. And so how he was able to formulate his atomic theory was that he studied ratios in elements combined in chemical reactions. And so what he saw was that when atoms were mixed, they're able to maintain their identity. Well, unless they combined in a chemical reaction. And so he was able to identify the ratio of these atoms coming together, or these elements coming together to create these different compounds. And so looking at the structure of the nuclear atom, Thomas was able to discover the electron during a cathode ray experiment. And so he believed that the electrons were like plums. They're embedded in a positively charged like pudding or an area. Thus, it was called the plum pudding model. So if we look at this model here, what he thought is that electrons were kind of just stuck in a pudding. You know, they're kind of like stuck in the mud, right? So electrons would just fly in and they're just stuck there in this pudding or this mud field that had a positive charge. So again, the electrons were attracted to the positive charge and they got stuck, and they were stuck in that, what Thomson calls pudding. You could think of it as like throwing rocks in the mud. It's just going to stay there. Okay. And so Rutherford in 1911 was able to debunk that. And he was able to use a gold foil experiment to discover the nucleus and essentially the basis of the structure of the atom. So instead of having that pudding of like an electric charged pudding, he was able to identify the true structure of atoms. And so after doing the gold foil experiment, he was able to conclude that electrons are going to be outside of this nucleus, or this positively charged nucleus. And so most of the atom that we see is going to be empty space. What we see here is that the nucleus is going to contain both that positively charged proton and that no charged neutron. We'll talk about that later. But he explains that these electrons are going to be outside of this nucleus. And so the electrons, neutrons and all that, is that the protons and the neutrons is going to be the mass of that nucleus. And so when we look at his gold foil experiment, what he was able to find was that after shooting a light into this gold foil, he was able to see that light was able to pass through most of the foil, but not all. And so if we were to go with the plum pudding model, he should expect all the particle light to go through without deflecting in different areas. So again, the electrons would be scattered, but we see that the light's able to go through. But what we see with Rutherford's model that debunked the whole idea of the plum pudding model was that as he shined the light through, he was able to get it through the electrons. But when he tried to shine the light into the nucleus of the atom, it bounced in different directions. It wasn't able to go through the nucleus, it bounced in different directions. So he was able to hypothesize then that, there was a nucleus there that's made up of some positive charge because of the deflection that was seen there. And here's the diagram where we see tries to pass through and it deflects. And so again, when we look at Rutherford's model, we see that yes, there is this nucleus, that it is positively charged nucleus, and that there's an electron field that surrounds this nucleus.